In this video, we'll be looking at the last stamp of problems, and that is problems number 32 to 41. For number 32, we're to match each equation to its graph. All right, and we see that they are all exponential function problems. All right, there are a couple of quick things that we know about exponential function problems that will allow us to match these. First of all, if we have y is equal to, and for all of these, we're going a times b to the x minus h plus k. All right. If we look at our k value, and we only have one with a different k value, that's c. All right, and that'll let us know that, well, y is equal to k is your asymptote. All right, and so for c, we have a different asymptote. Y is equal to 2. All right, so that lets us know that this graph is c. All right. And if we look at our b value for the graphs, they'll tell us a little bit more for maybe a different problem. All right, when b is between 0 and 1, all right, we have a decay. All right, now knowing that, the only b value that's between 0 and 1 is problem D. All right, that's the only one that's a decay. All right, and so if we look at these three graphs, we see that they're gross, and this one's a decay, so this is D. All right, and that leaves us with the other two. All right, now one way to do all of these problems is just plug in a 0 value for x. All right, and solve. So if I plugged in 0 for a for the first one, all right, we get 3 to the 0. 3 to the 0 is equal to 1. All right, and 1 times 2 is 2. All right, so we could look for which one gives us a y-intercept of 0, 2. All right, that would be this one. Roman numeral 2. So that one's A. And we can go ahead and check this one, but we're pretty sure what the answer is. If I go 0 again, 0 plus 2 is 2. 4 squared is 16. All right, and so we'll look, and we see that the y-intercept is up here somewhere for this graph, and that leaves us with B. All right, problem number 33, you're matching again, and we're pretty much trying to find different ways to figure out which equations we're dealing with. A, B, and C are all exponential functions, and D and E are both log functions. All right, I wrote a little bit up here for you to help you with the vertical asymptote versus the horizontal asymptote. All right, when we have a log function, we have a vertical asymptote where x is going to be equal to your value of h. All right, so I'm going to do this kind of backwards, where we're dealing with D and E first. All right, and if we look at function E, all right, we have y is equal to log base 10 of x plus 2 minus 1. All right, and we see that our h value is negative 2. All right, that's going to be enough, all right, where we're saying that our vertical asymptote is equal to negative 2. That's enough to get us to our answer for that problem. So we're going to say, all right, as we look at our asymptotes, that this one is E. All right, and then that leaves you with one more log function. All right, this log function right here has to be D. All right, now the other three graphs are exponentials. All right, and so first of all, we see that this one's increasing, this one's increasing, and this one is decreasing. All right, so we need to change one of these three functions. Now, the one B, or B, has a negative exponent, and when we went through problems like this, all right, e to the negative x, we can't have that negative exponent, so we usually change that. All right, we make that y is equal to 1 over e to the x. All right, and so we can see that this is the one that's going to be a decrease. All right. Now, of the three, that one would be B. All right, that leaves us with the other two problems. All right, and if we look at our asymptote, all right, the asymptote for this one is -3, which goes with A. All right, because of this value right here, and then that leaves us with what? C. For number 34, it says write an equation relating the variables. Use K for the constant of variation. So I wrote you a little note up top. It just says first variable. All right, if it says varies, we're going to put the K. Directly or jointly, we're going to put the variables next to, and inversely means we're going to put the variables underneath. So we could quickly do this problem. We say for letter A, it says S varies. So that lets me know that I'm going to have S is equal to K. All right, and it says directly as R, so directly next to. All right, so S is equal to K times R. Done. B, Y varies, so Y is equal to K. Varies inversely as X, so the X goes underneath. Letter C, keep it moving. All right, T varies, so T is equal to K. It varies directly as R, so the R goes next to, and inversely as S, so the S goes underneath. Letter D, V varies, so V is equal to K, jointly with R and H, so jointly and directly, very similar. All right, R, H. Question 35. If Y varies inversely as X and Y is equal to 2 when X is equal to 25, or Y is equal to -2 when X is equal to 25, find X when Y is equal to -40. So when we have these problems, whether it's a long word problem like number 36, which is coming up, or this one, we have 3 steps. All right, 1 is to find the constant of variation. 2, write an equation with the constant of variation in it, and 3, answer the last question. All right, so first things first, Y varies inversely as X, so Y is equal to K over X. All right, so we're trying to find K. All right, we're going to plug these values in. So we have -2 is equal to K over 25. All right, if I multiply both sides by 25, I get K is equal to -50. We circle that. That's our first circle. All right, next, take that, plug it back into where we started to write an equation. Y is equal to -50 over X. That's the second part. All right, and then the third part, all right, answer the last question. Now that you have the equation, all right, it says find X, all right, find X when Y is equal to -40. All right, in this case, there are a couple of different ways you can do this. If you're just at a primary level of solving, we're going to multiply both sides by X. That'll give us -40X is equal to -50, and then divide both sides by -40. All right, that'll give us X is equal to 5/4. Now some people can get that answer a little easier than we got it, but that's how we got it. Number 36, the time T required to empty a pool varies inversely as the rate R of the pump. So a lot of words here, all right, and so we want to take the words, we want to take what's important out. So we have T varies inversely as R. All right, that's what we want from the problem. All right, if we take that out, we get T is equal to K, that's the T varies part, inversely as R. All right, there's our important part. All right, next part, because we got to get K first. All right, one pool takes 60 minutes 60 minutes to empty at a rate of 230 gallons. All right, so there's our equation. Multiply both sides by 230. All right, that's going to give us a K value of 13,800. We did this problem together already a couple of times, actually. It's the exact same problem, nothing changed. All right, got your K. All right, which means that you can now have a relationship. You can write an equation that represents the relationship between T and R. All right, that's T is equal to K over 13,800. All right, we found, it says find the constant K. We found the constant K, so we got A, done. We have B, all right. And I actually think this is the A that they're talking about, but you got it up there. All right, and then C, all right, always a last question. All right, C says, how long will it take to empty the same pool with a pump that can empty at a R rate, or rate, of 300 gallons per minute? So, oh, I'm sorry, this is wrong. It should be 13800 over R. All right, so if that's the case, we have T. It says how long? 13,800 over 300. All right, and remember your time in this case is going to be equal to 46, and we're talking about in minutes, so it's 46 minutes.